Let's find center of mass of a semi-sphere. Here the center of mass of the semi-sphere would be somewhere here at this point, because the center of mass always acts towards the more mass region. So from this point to the right side, if you see, the mass region is less, but to the left side more mass is concentrated to the left side. So center of mass will be moving closer to the more mass region. So this location, this length from the origin, we are going to trying to find the length of center of mass from the origin. So for this we have some formula. Before that, I want to give instruction how are we going to do outline. I'm going to give the outline. What are we going to do? We need the volume of a sphere and we need the volume of a disk volume and semi-sphere volume of semi-sphere. We need it. So why do we need this disk? Because in this semi-sphere we are going to cut a piece and it is a disk. When you cut this, will be having some thickness. This thickness will be dx, and it has the radius from here to here. The radius of the disk is simple r, and the radius of the semi-sphere is capital R. So first we will be writing the formula of the semi-sphere and the disk. Semi-sphere formula is 4 by 3 pi. The radius is capital R. Here why there is 1 by 2? Because it is a semi-half sphere. Full sphere has 4 by 3 pi r cube. So we know the formula of semi-sphere. Now we cut the small piece. So this volume we will be taking as delta V, dV. So here is a dV. The disk volume of the disk is area multiplied by height. Area of the disk is a circle, so it should be pi r square, simple r, because the radius of the disk cut piece, the radius is r, simple r, multiplied by the thickness. What is the thickness of this disk? Here is the thickness. It is parallel to the x-axis, so it is dx. Thickness is dx. So this is the volume of the disk. Now this is our first step, step 1. Now we have the formula of the both volumes. And step 2, we are trying to find the value of, or the formula of, the radius r, simple r. How are we going to find? Now you can see a right angle triangle from here. This length is the radius r, and this length is the radius of the bigger semi-sphere, capital R. And this length from the origin to the slice, this one we are going to take as x. So x, this is not x-axis, this is the length from the origin to the slice, x. Now how are we going to find this r? We need to know the Pythagoras theorem. Pythagoras theorem says the hypotenuse r square is equal to the square of two sides. So I can find r square. This x square will go the other side. So r square minus x square. Now we have the formula for r square as well. That's just step 2. So we finished step 1 and step 2. And what is step 3? Step 3 is the formula of center of mass for the x-axis. That is x dV divided by the volume of the sphere. So what is here? X is the length and dV, the length of origin to the slice is x, and dv is the volume of the disk. We found here it is. So write this value pi. In the place of r square, I'm going to write this value. So in the bracket r square minus x square, that is r square value, multiply by dx. So right here dx divided by the volume of the semisphere is written here, 1 by 2, 4 by 3 pi r cube. So here the constant value you can cancel out for simplification. You can cancel this. Now the limit is here 0 to r. That is the maximum limit for the semisphere, the radius 0 to r. Now we are deriving and doing the calculation one by one. 0 to r. Now this is multiplied by this. X times r square is x r square. The dx is common, so dx, and here is a minus, so put here minus, another integral 0 to r, the limit. This time this x is multiplied with another x square, so x times x square is x cube, and dx is common, right here dx, divided by 1 by 2, 4 by 3 r cube. So we can cancel this also, right? Okay. Now r square is a constant, so it will be there outside. Now x dx integration is x square divided by 2, and the limit is here 0 to r, minus x cube integration is x to the power 4 divided by 4, and the limit is here written. Now here what is there? 2 by 3 r cube, 2 over 3 r cube. Okay, now we are applying this limit, upper limit and lower limit. First we apply the upper limit minus lower limit. Lower limit is 0, so the total factor will be 0, so no need to concentrate on 0, just concentrate on this r. So write first this r square. So when you substitute this r in x, this will be r square divided by 2. Here is a minus, minus. When you substitute this, it will be r to the power 4 divided by 4, and whole divided by 2r cube divided by 3. So let's simplify again. So this 2, if we multiply, r to the power 4 divided by 2 minus r to the power 4 divided by 4 whole divided by 2r cube divided by 3. So equal. It is equal to, when you cross multiply here and here, it will be 4r to the power 4 minus 2r to the power 4, and the denominator is multiplied. 2 times 4 is 8. It's a mathematical calculation. Whole divided by 2r cube divided by 3. When you subtract these two terms, you will be getting 2r to the power 4 divided by 8, multiply by, take the reciprocal of this. When it goes to the top, it will be 3 divided by 2r cube. Now this r cube, and here 4r is there, 3 is cut. So this 2, this 8 is cut. So what is the remaining on the top? 3 times r, 3r divided by, what is here? 4 is here, 2 is here. 4 times 2 is 8. So this is the center of mass of a semisphere in the x-axis. That means this is the total radius. 3/8 of 3/8 of the total radius will be the location of the center of mass. If you divide the length by 8 times and the 3 part, 1, 2, 3, the third part will be the location of center of mass from the origin. So if you divide this complete length by 8 times, and if you count from here 0, 1, 2, 3, so here will be the center of mass. Thank you very much.